Okay, so this is a quick rehash of what we went over in class on Friday, November 9th. We have my interpretation of the heart 4 times here. The one over on the left, this one is in, let's see, let's pick yellow. This one is in diastole. Oh, let's go back here. This one is in diastole. While it's in diastole, there is still blood rushing into the right atrium and the left atrium. But because these two valves are open right here, and right here, the tricuspid and the bicuspid, all that blood is going to end up filling up the ventricles. So the ventricles are all full of blood. Blood's still going to come rushing in. Now it's going to fill up the atria. They're completely full. Okay, and at this point, we're going to have the SA node right here is going to fire and send a signal down to the AV node, and it comes across here through Bachmann's bundle, causing a contraction of the atria. I tried to make the atria smaller there. This is going to send all the blood down that was in the atria is now going to be down here in the ventricles. That contraction of the ventricles and the additional blood that is moved in there is called atrial kick. If the atria didn't contract, you wouldn't get atrial kick. You'd still have this blood right here, but you wouldn't have all of this blood. So the atrial kick is now down in here, and now we go into a period of waiting. And if you see in the heart, it's still full of blood. Ventricles are full of blood down here. Actually, there's blood again rushing into both the atria, but it can't get down into the ventricles because they are stuffed full. And now, after the signal actually is, let's see, we've got the pink, right? Oh no, let's see, let's do light blue. Okay, so our signal is stuck right here in the AV node. And it's delayed for a while, and that's represented here on the electrical sketch by just a flat line. This gives the atrial kick blood time to get down into the ventricles. After a short pause there, we're going to get, let's see, we're going to get the signal is going to go through the bundle of His, through the two bundle branches, and through the rest of the Purkinje system, causing a wave of contractions upward. And that's what this is. You see the ventricles are now empty of blood. Of course, the atria are full of blood because they were filling over here. The ventricles have contracted, and that's going to give us a QRS complex down here. Okay, so we end up with, okay, so we're going to end up with something that looks like this, straight line. And we're going to go with this one. We're going to have a little P wave, another straight line, and then we're going to go down, 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 here. So again, this is the P wave, which represents atrial contraction. This entire thing is called the QRS complex. This is actually the R, and this is the S. And like we said in class, most people don't have a Q. If you had a Q wave, it would be right there. Most people don't have one because Q waves indicate dead heart tissue. It means they've had a heart attack before. Most people haven't. And then this thing over here is called the T wave. There's no contraction going on when that electrical activity happens. What's actually happened is that the sodium and the potassium that changed places to make the QRS complex are moving back to where they came from. And that is basically what we went over on Friday, November 9th.